Hey, what's up guys? This is Free Bonfire back with an amazing tutorial. Today we are going to talk about liquid donuts. Yes, that sounds a little bit ridiculous, but you can see the result is visually pleasing and it's a fun technique. So why don't you learn it, right? Yes, basically you will learn how to fill up any object, in this case it's a torus or a donut, with fluid simulations, giving them different densities to achieve beautiful mixing patterns. Yeah, sounds complex, but you will see it's fun and easy. So you can see here are some stills. They also look lovely. This is an easy test with the mixing. I like this green one. Yes, the OpenVDB meshing here is quite beautiful. A simple test with turbulence. Also nice. Something quite similar, but also a nice pattern here. And a close-up shot there. So you want to learn that stuff, this is the right place. Let's get started. Alright guys, so why don't we have some fun in Cinema 4D? Maybe you start with a plane, so we have something as a floor. And next, you should grab an object you want to fill with fluids. So this is our topic, mixing different fluids in a donut or a torus. But of course you can take whatever object you like a figure or something. But in my case I grab a torus and I like the numbers like this. Quite lovely numbers. Put it on the floor. Alright, so this is a nice subdivision, so don't work with something like this, because it gives you ugly edges here. So be reasonably round here. Alright, since we want to work inside the donut, this view is not so helpful and this is not so helpful too. So we should put an, where is it? The display tag on it. And we use something like lines. This is quite complex, but when you put it to isopalms, this is the perfect view for our task here. Next, I would say we put an emitter inside the torus. Put it to a spherical emission because it should be quite organic and I don't want to emit from a rectangle. Alright, so what is happening here? Yes, this is not colliding with the donut. Just give me the word donut here. So I would go to X particle tags and put a collider on it. And we want the particles to collide with the inside. And we neither need bounce nor we need friction. Let's see. Yes, this is quite promising. And if this is all you want to learn here, yeah, you can already be quite satisfied. But I think we can do even better. So maybe we just switch the display to circle filled. This is giving us a better representation of the radius of these particles. And maybe we should also emit a lot more of them, like 8,000. And by the way, when you set the radius to 1, you can see you get little spheres. Oops. But for this demonstration's sake, 3 is good enough. But when you want to have more resolution in it, of course you need more particles here with less radius there. Something like this. Giving you a better resolution, right? But we go to 8,003. And overall, this is quite boring. So maybe now is the time to put in FluidFX. And this should be instantly quite interesting. No, I promised too much. Maybe we should switch the emission to shot. Put it to 8,000. Let's see what is happening now. Whoa. So this is super brutal. Wow. Instantly in one frame this is exploding. This is happening because FluidFX giving these particles physical behavior. And when you want to compress like atoms, like particles of fluid, in this tight radius, they will have some explosiveness to them. So this is like small like a black hole, like giving a real brutal shockwave here. But so the bigger you make the radius of your initial sphere, the less explosive it is. But maybe you want to have it small. This is too intense for you. So in this case, you would go to the FluidFX and change the internal pressure. Put it to 50. Let's see. Takes out a little bit of the pressure. Put it to 20. Already too smooth. Maybe. Okay, I guess I like this number. Yeah, this is totally fine for me. So it can be explosive, but not too explosive. In general, when you work with fluids, you don't want to have compressed particles, but in this case, it's super helpful. If you don't want it, you should go to a mode like hexagonal. You see, the particles don't collide with each other. They're not so densely packed, so they have a distance from each other. Or you could go to something like regular. But let's go back to shot, because this is what we want. Yes, this is a good start. Should I make another emitter? Let me think about for a minute. No, not for a minute, for 5 seconds. So yeah, let's grab another emitter, because this is a little bit boring. Let's go to the display and say this one is orange. Yeah, something like this. What is happening? All right, we already get some mixing. Maybe give me more frames there. And this line here, this is quite interesting. So yes, this is mixing, but I think we can get even better mixing behaviors. So this is a little bit boring, and I think it has to do with the external data, with the fluid data. Let's talk about density. So both of these ones have a density of 1000, and 1000 is the physical correct value in real life for water. It's 1000 kilograms per square meter. I think this is the right description. But all kind of materials, objects, they have different densities. For example, if you want to have a water that acts like an apple, you would go with 700, because an apple has a density of 700. Standard rock has 2700. Lead or lead, I don't know how it's called, has something like, no, it's, yeah, this is quite high. Mercury, hope I'm not fooling you. Is it something like this? I'm not sure. And concrete is something like that. Air is 1.3. Steel, 7800. So yeah, every material in real life has different densities. Let's go back to 1000. So if you want to have the green particles being heavier and pushing the orange ones away, you could say this one has a lower density. Now, when they come together, it should be like, yeah, green is pushing through the orange ones, pushing them aside, and you get lovely curls here. So this is yes, look at this one, it's beautiful. So if you want to have better mixing of your fluids, you should play with the settings, with the density settings. Yes, so what else could I explain? Here, when you go to this one, we already played with these parameters. We could maybe be a little bit more interesting here, put some more emitters inside. So where is it? Display. We put this one as red, red. Now we mix 3 fluids. This is nice, but I think the density is the same, so maybe we should change this one. And when I do this one, I could already do some blue particles. Let's make them blue and change the density to maybe 200. So we have 200, 1500, 500 and 1000. This could be more interesting. Let's see. Yes, really lovely curls. I like it. So this is the main principle of this tutorial. Wow. Yes, this is giving nice patterns. Maybe before we go to the next section, viscosity here makes it act more like honey. So maybe we make all of them more like honey. Vorticity, giving them some fake little turbulence, like a turbulence for free. Let's see what is this doing. Reminds me of a certain logo. So yes, you get more little twists, and I think this looks even better. Maybe surface tension makes your particles act more like, how can I say it? It tries to minimize the surface. Therefore, big parts like this red one will form smaller, rounder shapes because it tries to minimize the surface, all right? So when I say putting this one to 100, I'm pretty sure you will get more smaller sphere-like structures. Let's see. Didn't change so much, but it already looked quite cool. So maybe get rid of the floor. Yeah, so I mean, these are nice structures here, right? One last thing, let's try to put a turbulence in it. And I just like curl noise, and I like to put this blend and add a little bit lower. And let's say after 60, the strength will reduce from 10 to 0. Give me a couple more frames. Let's see what this turbulence is adding to it. Okay. Last test here before we go to the next part. Yes. Oof. This is beautiful. This is just beautiful. Yes. Super nice behavior. I would love to eat this liquid donut. Nice. Really nice shapes. Alright, cool. So this is the basics. Let's go on. Hey guys, just a super quick intermission. I just wanted to say thank you so far for following my channel 3D Bonfire. So far 3 months. This has been an amazing ride. So much fun here to share this knowledge. I started with these ones. Yeah, you seem to like digital nature. Now I'm going more into the X-particle stuff, explosions, fluids, fire, smoke, all the good stuff, all the fun stuff. So this will definitely develop into something super cool, and I'm totally passionate about it. Just one small thing, if you give me a little love back and support me in doing these tutorials, you can do me a huge favor and share some love if you want to become a tutorial supporter. Of course, this is, you don't have to do it. You always can enjoy this stuff, but when you want something additional, so for all the YouTube tutorials, there will always be a little bit bonus content for my patrons. So if you are really into this tutorial learning stuff, this is the way to go. Also, you will get access to my scene files, and you feel like an amazing person to share the love and help me support me doing better tutorials. Yeah, so yeah, 3D Bonfire on Patreon now. That's great news. Also, this is me, by the way, Markus 3D. I live in Berlin and I'm an artist working here. And if you want to get a feeling what would be the next tutorial and stuff, yeah, why don't you consider following me? So you can see I uploaded these donuts and someone said, hey Markus, maybe you can do a tutorial about it. And I said, yes, that would be great to share. And this is how this developed into a tutorial on 3D Bonfire. So thanks guys, the tutorial will continue from here on. Next, we should talk about how to turn your software preview here into something lovely you could put on your Instagram. So you want some quality like this. You already seen these ones, but you need particle shading, some textures, light. I think we can't talk about everything, but you can see you need some nice representation for your particles. You can mesh them into an OpenVDB volume, or you can render them as spheres in different sizes. So this is quite lovely. And yeah, I already showed these ones to you. This is more like a software preview, but with a nice shading. So we should talk about how to visually represent your particles. Alright, so maybe we just study this scene file. This is pretty simple. Where's my viewport? Come on, okay, there it is. Alright, so we have a representation of our colored X particles with little spheres. And yeah, so basically this is super simple. These are my two emitters, maybe switch one off. So if you want to render one emitter, this is also quite beautiful, but we want to show both. The trick is, go to your emitter, put an Octane tag on it, go to particle rendering and activate the geometry. If you put a sphere, for example, or whatever object you like into the geometry, this will be the representation of your particle. So the blue one has a representation of particle 1 of the yellow one, and the yellow one has a representation of the blue particle. So okay, this would be other way around, but you get it. You could change the particle radius, for example. So you see now these ones get bigger and you get a nice border here. So whatever you put in your particle will be the representation. So this is quite nice. Actually, I really like this border. So why don't we use this one? But you could also go to your material, maybe make a specular and go with the roughness a little bit up. I don't know. Yeah, ooh, this is looking nice. So maybe that it is so black is depending on the depth of the specular. No, okay, I'm wrong. But yeah, this is looking super nice. So already learned something, right? You just use particles as a representation. Cool stuff. Next, I think the interesting thing here would be how to use an HDRI. Because now the scene is super black, maybe you and your Octane setup still has white into this default environment, which gives you an overall white illumination, which looks interesting but super dull. So get rid of this one, switch to black, and now use an Octane Sky and put an HDRI into it. You want to do it like this, so you put your environment and here click on the image and then here you put the HDRI into it. You can see the basic values here are 1, 1, 1. Remember these ones because you can see in my case I go a little bit crazy with these values. And this is really a useful trick here. So you can see this HDRI looks super boring and you think, this isn't working for me, but you can really go crazy with these numbers because you have a lot of exposure values in your HDRI. So you could put a lot of power into it and now slowly change the gamma. So when I go higher here, now I go more into the red tones. See, this is getting too vibrant here, but I think this is a quite lovely look. Let's see what happens with 15, too dark. I stayed just with 20. So this is beautiful. Here, the rotation, I always love to play with this one. So maybe first the rotation Y in the Y-axis. I angle this middle line a little bit beneath the horizon because now this is quite intense. I need to correct myself. this looks super nice. But when I go down maybe a little bit, okay, this is already too far, maybe 2.5. Now I get a mixture here. Now the floor isn't so vibrant like in this case, but oops, maybe I'm missing a 0. Minus 0 too much. Yes, this is the value I prefer. And of course the rotation Y just gives you different looks here. So yeah, I mean, all of these angles look nice. I like the highlight there, so maybe this would be already the lighting for the scene. Super beautiful. So now you learned how to color your particles, how to render them, how to light your scene in an easy and efficient way. By the way, I use path tracing, and I think also for the final rendering 200 or something like this could also be enough. And yeah, not so complex stuff here. Maybe you are also interested in, let's see. So the basic material looks a bit boring, but with some nice sketch lines here, this looks way more interesting, right? So this is an easy trick to make your renderings much more interesting. And the thing is, just in the diffuse, you just grab the tile shader. I already applied it to it, so the tiles, and I put it to squares, but you have so much versions here. So yeah, you can really go crazy with this ones. Sometimes lines is also nice. Let's see, sawtooth. I mean, I don't really need that crazy stuff. And maybe just let's go a little bit crazy. I mean, this is additional. You can already quit this tutorial here. But I just want to see what happens when I put these tiles maybe into displacement. So this could be interesting. It's a little bit dense here. So what happens when I put this also here? Okay, this is because settings, I think the shade, oh, it's already at 2000, 2K. So it has to be inside of here. Put this to 2K and maybe even put it to 4K. And let's see what happens when I put this one to black or some gray tone. So this is cool, right? Give me a 2 here to catch even more shadows on the floor. I mean, I don't like the pattern that much, but hey, this is adding something, right? All right, cool. So now you got the tools to make your render beautiful. Okay, quick addition. If you are particularly interested in this scene file, you want to know how I set this up, the OpenVDB jelly stuff here, the particles, the light and everything. This will be shared on my Patreon, and in the bonus lesson there I will quickly talk about the materials and basically the whole scene. Quick reminder, this was this rendering. Let's see. So yeah, beautiful. Alright, one last thing. So if you like numbers like I do, these videos could be super helpful for you. I give you a short preview here, but I have to say this is Patreon exclusive. I did like 18 tests and compared different settings, and maybe this could be helpful for you. So, but you get a free preview here. So you can see these are the settings for this donut number 6, the fluid modifier, emitter settings, turbulence, the further emitter settings here, and the collider tag. And in this case, I changed the viscosity. So for the blue and the yellow emitter here, I have a viscosity of 10, but for version 5, I switch it to 150. And obviously, you can see that these kind of shapes hold together in a quite different way with higher viscosity. I mean, this is not surprising, but it's good to see. And yeah, so if you like these compare videos, I made a couple of them and I hope you will enjoy them too. So hope you learned a lot, guys. See you in the next tutorial. Bye.